Okay, Assalamualaikum and hi everybody. I am Noazira Umaira. Okay, today I would like to share with you about Lab 4 power losses with my partner Nurul Husna. Okay, first we must add the bus here. Then we set the value based on value that given on lab sheet, which is 13.8 kilovolt. Then we click on system select bus. Okay. Then we must make sure the position is correct. So this one is up and up position. Alright. Next we do the same thing to insert the bus 2. $30.8. Which one is right? System select bus. Okay. Okay, next we add the generator at bus 1. Oh, sorry. Generator. Okay, we set the value at set point is 8 megawatt. And for MVA output is 4. Okay, and the position at left. Okay. Alright, next we add the transmission line. Here, transmission line. Alright, we set the impedance value at series resistance to 0.5 and the series reactance is 1.0. Then we must set the MVA limit at limit A to 50. Okay, click OK. Oh, sorry. Okay. Alright. Okay, next we must right click on bus 1. Okay, right click on bus 1 and select add new field. We go to add new field around bus. We choose the position 6 and we click on bus voltage kilovolt to display voltage at bus 1. So click OK. So this is the voltage value at bus 1. Then we do the same thing at bus 2. So right click. We go to add new field around bus. Position 6. Click bus voltage kilovolt. Okay, okay, right. Okay, next we add load at bus 2. Load at bus 2. Then we set the constant power for megawatt is 8. MVA value is 4. Then click OK. Okay, next we must double click on load megawatt. Double click. Okay, we set the digit right of decimal to 1. Delta per mouse click to 1.0. Okay. Okay, we do the same thing at MVA field. at digit right of decimal at 1, and we set the data per mouse click at 0.5. Okay. Alright. We done for this part. Okay, next, we must add the switch shunt at pass 2 also. Okay, we must add the nominal and var at 0.0, and we choose the discrete mode. Then we must set at envar block at number of steps at 20. So at 20, and envar per step at 0.5. We click OK. We just alright, we must also we must double click envar. We add digit to right of decimal as 1. Digit per mouse click as 0.5. Click OK. Okay, next we must right click on one line. We go to one line display option and go to animated flows. Okay, next we must adjust the size. Okay, we adjust at 100 and the density at 10. Okay, so for this flow, we must set at actual megawatt and mega var to display the blue arrow at transmission line. So we click OK. Okay, next, to display the real and reactive power losses, we must right click on transmission line and choose OK. And we go to add new field around line or transformer. We choose at position 6. Okay, we go to we choose at megawatt losses. Okay. Click again. Add new field. Position 6. Envar losses. Okay. Okay, now we try to run this simulation. We change to run mode. Go to tools and run. Okay, we adjust the value of capacitor to 0. We go to 0. To see the initial condition when the capacitor value at 0. We can label this simulation. We go to draw, background and text. We add the text. Okay. Real power losses. Okay. For reactive, we do the same thing. Add text. Reactive. Power losses. Okay, done. So when we, this is the initial condition when the capacitor value at 0.
Okay, next for the simulation part, we will observe the value of the capacitor and how it affect the value for real power losses and reactive power losses. Okay, now I will start it with the zero point 0.0 MVAR capacitor value. And we'll see that the real power losses is 0.48 megawatt and the reactive power losses is 0.97 MVAR. Okay, the value the value that we get, we will put it into the Excel because later we will do a graph. So all the value I put it here. Okay, next. When the capacitor value is 0.4 MVAR, the real power losses is 0.46 megawatt and reactive power losses is 0.2 MVAR. And the value we put it here. So then when the capacitor value is 0.8 MVAR, the real power losses is 0.44 megawatt and reactive power losses is 0.87 MVAR. Then, when we increase again the capacitor value to 1.3 MVAR, the real power losses is 0.42 megawatt and reactive power losses is 0.83 MVAR. And we put this value to the Excel tool. Then, when we increase the capacity value to 1.7 MVAR, we can see that the real power losses change to 0.4 megawatt and reactive power losses also change to 0.8 MVAR. Okay, when I do all the simulation, I will get all this data. As we can see, the different value of capacitor it gives to different value of power losses and real power losses. From the from the data, we can get a graph. Okay, so here is the graph. It will decrease and increase back. As we can see here that power losses value decrease until 0.35, it will constant, and it will increase until 0.5. While for real power losses, it also decrease until 0.7 and it will increase back until 1.01. So we get the value, we get the graph as like this. Okay, so now we will get the value of QCAT that minimize the real power flow into feeder. Okay, so the real power flow, we will see the value and see that the 0.35 is the minimized value that we can get. So for the lowest value of power losses is 0.35 and we get the QCAP value is 3.6, 4.1, 4.6, 5.1 and 5.7 MVAR. Okay, next we will see the value of QCAP that minimize the reactive power flow into the feeder, which is we will see the reactive power losses. The lowest reactive power losses value, which is 0.7 at here, and we will see the QCAP is 4.1, 4.6, and 5.1 MVAR, as the graph shows the lowest tools. That's all from me. From the next part, my partner, which is Razi Omaira, will explain it more.
Okay, next, for the step F here, the question asks us to identify the real power losses, reactive power losses, and also voltage drop. Okay, now to identify the real reactive power losses, we need to refer the result table that we had construct in Excel. Okay, this one. Okay, we use the lowest power losses value, which is when the capacitor value at 4.1. So the real power losses at 0.35, reactive power losses at 0.7, which is the lowest one than others. Okay. So this is the condition when capacitor is at 4.1 amvar. Okay, we can see the value of voltage at bus 1 is 13.8 kilovolt, while the voltage at bus 2 is 13.19 kilovolt. Okay, for the voltage drop, we just need to get the difference between bus 1 voltage and bus 2 voltage. Then we get the value of voltage drop, which is 0.61 kilovolt. Okay, so for the real power losses, we get 0.35 megawatt. Reactive power losses, we get 0.7 megawatt. So, and the voltage drop is 0.61 kilovolt. So, that's all from us. Okay, thank you.